Hello guys, as you may already know, I'm making bioplastic, and I'm recording a video because the process would take me about 20 or more minutes to finish, so it's impossible to finish it in the class. So yeah, this is it. These are the 4 ingredients I'm using. I'm using glycerin, which is 95% glycerol, about 1 tablespoon. I'm using white vinegar, another 1 tablespoon of it. I'm using cornstarch, which was initially supposed to be gelatin, but due to the fact that we don't buy gelatin because of religious restrictions, I'm just using cornstarch. The difference between gelatin and cornstarch is that gelatin is a protein-based polymer, whereas cornstarch is carbohydrate based. So it would give a more rubbery structure to the bioplastic and more milky color. Here's the powder itself, the starch. Also 1 tablespoon, and then water. I'm using Kirkland. Sorry for the promotion. Yeah, I'm using water, and I use 4 tablespoons. Now we're gonna start the mixing. So first we're gonna place the starch. Then we're gonna add the water. Mix it up. Add the vinegar and the glycerin. A little more. Now we're mixing it to get a milk color. Mix until you get a unified mixture. And then let it sit for about 20 minutes. So this is what the mixture should look like before I heat it up in the pot. Before I do that, I want to explain the science behind this. So in this chemical reaction, cornstarch serves as the base polymer, providing the glucose chain, specifically amylose and amylopectin, that form the plastic's physical matrix. The water acts as a solvent in the medium for a heat transfer, allowing the starch granules to hydrate and burst during gelatinization. Vinegar, as an acetic acid, is the catalyst for acid hydrolysis, where it chemically decomposes the highly branched amylopectin into straighter chains, which is one of the polymers that make up the glucose chains of cornstarch. And then this ensures the final material as a smooth film rather than a junky paste. And then glycerin or glycerol functions as a plasticizer, as small molecules wedged between the starch polymer chains, which were decomposed by the vinegar to prevent them from bonding too tightly, which keeps the plastic flexible and prevents it from becoming brittle. Yeah, so this is it. We're heating it in a low to medium heat in the pot. I want to spread it out so that it would be, as smooth as possible. It's pretty interesting to see how the bubbles are still visible. This proves that the cornstarch, the cornstarch polymers did decompose using vinegar, and like it has strong, I don't know how to say it. I guess like it has strong osmosis kind of properties. So nothing gets unpolarized. Everything's together like water. But yeah, so I'm gonna wait for about 1 to 2 minutes, and then we'll get this thing out. As you can see, the liquid form gradually fades away and turns to more liquid, pasty structure. I'm gonna heat it up a little more to get all the liquid out, and then I'll place it in the plate. So I just spread all of the plastic onto this plate, and then I'll dry it using hair dryer, which we turn this into an actual plastic. But you can already see the plastic structure of it, like a plastic bag you would find anywhere in the world. It doesn't have this vinegar smell anymore due to the fact that most of it got boiled and it evaporated. But yeah, these cornstarch molecules, when they were decomposed by vinegar, they were reconnected by glycerin, creating this gel-type plastic structure. But yeah, okay, so basically I scrubbed all of the product together and compressed it, and this is what I got. I wouldn't say it's a bioplastic. I would say it's more of a bio rubber, because how it's kind of squishy, and you can't just, it's not something that you can use as as a bag, like this kind of material. I mean, you can, but it's gonna be quite hard getting it together. So this is probably due to the fact that I used starch instead of gelatin. But so now to test it, I cut the bioplastic or bio rubber in like the longest radius, and we'll see the property of it of self-healing when I add some water. Okay, so I added some water to it. I can't really find the place where it has been cut. I'm joking, here it is. So, I mean, you can see some properties of healing. I mean, it took it like a couple of minutes to fully heal and compress again. I mean, this is not a successful product, honestly, but You know, it still shows it's still a prototype of what it's supposed to be. As you can see, like the outer layers are much more milky. This is due to the fact that I didn't have enough water when I was heating it, but yeah.